Here I am back in the drinking water reticulation system. This tutorial looks at matching the dynamic performance of a pump station's non-return valves to the transient behaviour of the overall system. Zooming into the pump station. The case study explores a situation with a pressurised air vessel on the delivery side of the pump station, and the station has two parallel duty pumps. When one pump stops, both the air vessel and the parallel pump have the potential to send reverse flow through the stopping pump. Your mission is to assess the impact of pump 1 turning off while pump 2 continues to run, with the station equipped with slow non-return valves. As this will be a normal and frequent operating mode, the aim is to use transient analysis to assess whether the station may have long-term maintenance problems due to the type of non-return valves. So let's do the analysis. Close the tuned outlet model if you still have it open. Then open the file named Pump Station in the Exercise 9 folder. That's where I am now. You will see that the pump station model has been made more realistic by adding the suction pipe from the source tank to the pump station and by adding the pump manifold pipes. Both pumps are running in the steady state, and the model is set to simulate customer demand at 7 p.m. Right-clicking on Reflux 1, noting its closing time is 1 second. Doing the same for Reflux 2. Right-clicking on Pump 2, set surge action, noting that its surge action is stay at constant speed. Right-clicking on Pump 1, setting its surge action and noting its surge action is power fails, and the power is to fail at 0.1 seconds. These settings mean Pump 1 will turn off 0.1 second into the simulation, while Pump 2 continues to run. Simulate mode, redo the steady state hydraulics, start the transient simulator. Now that the simulation has run, let me view traces. Let me start by double-clicking the report pump speeds. Just checking that pump 2 continues to run while pump 1 turns off, very rapidly due to the reverse flow. We will take a look at that in a moment. Returning to the other graphs to look at pump flow rates. Both pumps start with about 11 litres per second each. There is the reverse flow through pump 1, with some of that coming from pump 2, so the rest must come from the air vessel. Then pump 1's non-return valve slams shut here. Interestingly, the valve slam generates some reverse flow through pump 2. Within 2 seconds, the system has settled down, with no flow through pump 1 and pump 2 delivering about 17 litres per second. Returning to see what station velocities tell us. Here we see the maximum reverse velocity generated in the downstream manifold. That is going backward through pump 1. Here we see the reverse velocity in the station outlet main, between the air vessel and the pump station. This provides an insight into the degree to which the air vessel drives these outcomes. Note the reverse velocity in the upstream manifold. This suggests for a very brief period that despite pump 2 having its motor running, there is reverse flow or water compression if you like, all the way back toward the source tank. Returning to take a look at head downstream of the non-return valves. As soon as pump 1's non-return valve slams shut, there is a large head spike downstream of the valve, which helps to drive the reverse flow through pump 2. Yet everything settles down within 5 seconds. High pressure class fittings and delivery pipe appear to be essential to cope with this scale of head spike. Returning to take a look at head upstream of the non-return valves. Head at the discharge flange of pump 2 is normal. Head at the discharge flange of pump 1 crashes abruptly when the non-return valve slams, and appears that for about half a second the suction manifold reaches vapor head. Closing the graphs. I will leave you to use the envelope report to look at the exact values of maximum and minimum head at nodes around the pump station. And returning to the editor, I will leave you to repeat this assessment with both non-return valves edited to have 0.3 second closing times.